Okay, so my name is Youssef Ouertani. I'll be presenting the fifth place solution agenda for. I'll start with a background, well, summary of my solution, model architecture, data preprocessing, made training, how I load the data and methods
Can you
used.
present your slides? We don't see your slides.
Uh, So, okay. Well, the agenda, as I was saying, it does not differ from others. So we start with the background. So I am Youssef Ouertani. I'm a full stack engineer. I'm passionate about AI and actively transitioning into the field. I have an engineering degree. Therefore, I have a background in mathematics and statistics. So for this competition, I actually went full time and I left my first engineering role to participate. Summary of my solution. So uh, my solution is one architecture model and I examined four seeds of the same model. Uh, I did the test time augmentation, so spatial augmentations, rotations, and flippings. Each model took around 4 hours on GPU P100 provided by Kaggle. Uh, like other solutions, there's been patch splitting and stitching, probability thresholding, and connected components centers was calculated. So the model architecture. So each block N here denotes two convolution network with kernel 3 sequentially made, each followed by a batch number loop. For the input, I started with a batch norm 3D layer, so it kind of learned normalizations. For concatenation, for skipping, we use concatenation, and finally the output mask, which is a convolution of kernel size 1. So for data preprocessing, I applied the min-max scaling by average 599 percentile across 7 volumes. Label radius was log scaled. At here, I tried to make it look more like a center, not a particle. So I tried to make them all look have almost like the same size. And centers was scaled by 10.012, like we have in the data and in some discussions. So please feel free to ask me any questions if you have them. Okay. For training, so starting with the data loading, so my patch size was of size 128 times 3. For the data, for loading, while loading data, I feed them randomly by selecting random volumes. Batch size was used is 4. Uh, so while training augmentation, so spatial augmentations, we applied flipping along 3 axes and 90-degree rotations along the z-axis. Also, I did apply mean and standard deviation shifting by 3%. Okay, the loss used is the cross entropy. I use the label smoothing as cross entropy. The optimizer was Adam with a learning rate of 0.00301 and beta 1, beta 2 of 0.9 and 0.999. For training, also for inference, I used a float precision 16 for training. Also gradient clipping with a maximum of 1 for stability. Finally, the model, as was already been mentioned, it took 4 hours for 36 epochs. Each epoch being of, we feed 1,024 patches to the model. Moving to the post-processing and inference. So for reconstruction of the patches, I used weight averaging, where the borders of the patches gets a weight of 0, 1, and the center of 1. So for ensembling, it's an averaging of the probability of the 4 models. As I mentioned, also probability thresholding to maximize recall and identified connective components and calculate object samples. Okay, to speed up inference time, I used Python threading and the 2 GPU, split the testing data into 2 sets, and had each set run on a separate GPU. So for each tomogram, it took around 50 seconds. So in parallel, it's a 50-second inference for the 2 volumes. Question and answering.